Hello everyone, I present my project for the Redis Hackathon. It is called Tip Land. Currently many of the products we use have a tip of the day functionality where the user is shown the best ways to use the product, features to discover or ways to perform certain tasks more efficiently. With Tip Land, the idea of the project is to offer a platform as a service that allows developers to generate this functionality through a REST API. Now I will show the architecture of the project, which is divided into three main layers. As the first element we have the security part that is delegated to ClerkDev, which is a platform that allows you to easily integrate different login methods with social networks, and double-factor authentication for the back part. The Remix framework was selected because it provides many out-of-the-box functionalities for handling form processing and data loading, as well as being very fast both in development and in its execution times and its functionality. Nested routes just makes the job so much easier when it comes to dashboards, all using TypeScript and Tailwind for the data persistence part. Redis is used as the only and main database. In the project there is no other database, and everything is centralized in Redis. The Redis cloud service is used where I signed up, and access to the database is obtained. Thanks to Re2 Stack, there is a whole set of functionalities that perfectly cover most of the common scenarios that arise in this type of project, from writing operations, updating, queries or searches advanced, and it is also very fast to visualize the information that reaches the database. The Redis Insight application is used. Well, now we will move on to the main part of the project, the database. The data modeling is carried out by means of schemas provided by the Redis library. Let's see the database diagram in more detail. We have 5 entities: entity for users, the identifier returned by the ClerkDev, and the provider if it was a record through Google, GitHub or via email, is stored here. Entity for categories. The tips of the day can be segmented by categories, which is very useful if you have different products and want to have different tips for each product. Entity for tips. They are the data of the tip of the day, which are related to a user identifier and corresponding category. Entity for API key. It is the unique key that is generated automatically when a new user is created, and which is sent for the query of the tip of the day in the endpoint. Perfect. Now I will show how the data storage is. In the redis.server file we find the function that performs the initialization of the object managed by the Redis client, and the URL of the Redis cloud service is found in the environment variables. Within this DB folder are the functions that use the Redis Let's see a few. In the category.server file, we find the import of the Redis library, together with the import of the function for the client. Then we define an interface for the data types that this entity will have, and a class that inherits from entity and other types auxiliaries. Next, the schema of the category entity is defined with its respective data types, and whether the field will be indexable, which allows efficient use of searches, and then the function obtained by the repository for that schema. Here we can see the function to create a category that receives the name of the category and the user identifier, and through the repository creates and saves the new entity. Now we have the function to consult the categories of a certain user by means of pagination and ordering. In the same way the repository is obtained, and the filter is made through where, the ascending order, and finally how many records by an offset and total. In the file of tip.server, we find a similar structure where the data type is defined. The class that inherits from entity is created along with other auxiliary types. The schema, the repository, and the query functions are defined mainly by user identifier. Also further down we find the insert, update and delete part. For the other files, the mechanics are very similar. Define the class and its auxiliary types. Define the schema and the function that obtains the corresponding repository. Query functions, insert, update and more. In the dashboard.server file we find the functions that gestational the total figures that are seen when starting the application. Now we will see how these functions are consumed from Remix. In the tips we identify 2 large sections before defining the component of the root, which are loader and action. In Remix the loader function is the one in charge of bringing the information from the database, without any type of intermediary or calls to a REST API. This is where the function that consults the tips through pagination is called. Previously validating if the user has logged in. The action function is in charge of processing the form or forms that exist in a certain route. In this case, the intent field is in charge of defining what type of operation will be carried out. If it is a deletion, an update or create a new tip, everything submitting form data to this function is seamless. Remix has done an amazing job of providing a very smooth development experience. The Redis database is located in the Redis cloud service, and where the dashboard provides all the necessary access and metrics. Well, now let's see in general how it works. When we enter, it loads the home page, where it explains what the Land project is about. Later we go on to log in with an account through Google. Every time a user is created, a record is created in the user entity, and two additional things also happen, which is the creation of an API key, and a default category. Upon entering, we see the home screen that shows some statistics on the use of the platform. Right away there is the tips menu, below the categories menu, as the project is designed, so that the tips of the day can be segmented by several products. One tip can have a category. Then comes the stats menu that shows a graph with the total number of calls to the REST API in the last few days. Then comes the developer menu, which is very important. Here is where you get the API key that is will use with each call to the REST API. And below is the endpoint documentation. It is also possible to change the API key, if necessary. Finally, the profile menu, where all the information related to the user is managed. Surprise! Now let's see how the data arrives to the database, and it will be visualized through the Redis Insight version 2 program. I'm going to go to the documents section of the tip scheme, and I will see that no element is found. Now I go to the platform to enter a new tip. I will give you the value of test tip by description, select a category, and click on the save button. Now I check Redis Insight, and it verified that the new record is there. Done. The tip has worked. You have registered correctly. Now I am going to make a modification on the last record entered in the dashboard, and I am going to change the description, enter the new text, and click on the save button. Perfect. The changes in the user interface are reflected correctly. I will go back to the Redis Insight program to verify that indeed the description of the advice of the day has changed in the database. Perfect. The change is applied. Finally, I am going to delete the record and check that the change is indeed reflected in the dashboard. When clicking on delete, a modal appears where you confirmed that you deleted the tip of the day, and excellent is no longer in the UI. It has been removed. Again, I go to the Redis Insight program and updated the data to verify that this document is indeed being deleted, and perfect. The document is no longer found if it has been deleted.